and the paper is about the dual nature of the chemical element concept, a conceptual bridge inspired by Kantian philosophy. And Alfio and Andrea are both from the National University of Patagonia in San Juan Bosco. So it's very nice to hear people from exotic Patagonia.
Thank you very much for your presentation.
I'll interrupt when you've got 10 minutes left, just so you know.
Okay, so today's presentation is going to be about the dual nature of the chemical element concept, a conceptual bridge inspired by Kantian philosophy. I'd like to start by saying that the following is a work in progress, and by quoting Jorge Luis Borges as a trigger. If space is infinite, we are in no particular point in space. If time is infinite, we are in no particular point in time. This is extracted from the Book of Sun. This presentation deals with space, time, and infinity, starting from the distinction of Paneth in 1931 between the chemical elements understood in a dual way, as basic substances and simple substances. It is possible to conjecture that between these two manifestations, it can be postulated that there is a conceptual bridge, which in general terms is based on the perception of the element in space and time, as a spectrum of infinite manifestations between two extreme forms, the chemical element perceived in space abstracted from time, and the chemical element perceived in time abstracted from space. With the great advance of quantum physics at the beginning of the 20th century, the atomic theory was consolidated in the field of chemistry, beginning to assimilate the concept of element to that of atom. However, after the discovery of isotopes by Soddy in 1913, the elements seemed to multiply, and the doubt about whether or not they were new elements unleashed the so-called crisis of the periodic table. It is in the context of this crisis that Friedrich Paneth takes up the dual nature of the element concept, differentiating between elements as simple substances according to their phenomenological manifestations, and elements considered in an abstract sense as basic substances, to which he gave them as their only property, instead of their atomic weight, as Mendeleev proposed, their atomic number, in accordance with the new quantum mechanics. For Paneth, it is not about two descriptions of the same entity, the product of an epistemic limitation to be overcome in the future by better knowledge of it. According to the author, the concept of chemical element presents in itself a double nature. I will use two quotes from Paneth to help me develop these ideas. Probably no other example shows more strikingly that the simplest and most familiar scientific laws are only valid under the implied or explicit assumption of a transcendental world. And the atomic theory can, it is true, contribute enormously to, indeed, may be necessary for, visualizing how the basic substances persist in simple substances and compounds, but the concept of basic substance as such does not in itself contain any idea of atomism. Space and time as forms of perception. Kant, to explain how appearances arise, postulated an original conception of space and time, not as properties of things, but as a priori structures that allow us to configure the world. In this way, space and time are not properties inherent to the world itself, but to our way of perceiving the world. From these forms of perceptions, the subject can place the objects outside of himself and form a coherent image of them. But for perceptions to give rise to knowledge, other transcendental conditions are necessary a priori. The categories are pure forms of understanding. Knowledge, for Kant, is a result of a special conjunction of experience and reason. The subject requires the data of the senses in space and time to be able to build their intuitions, and of the transcendental categories to conform the knowledge of reality. In this work, I will use the Kantian philosophy as inspiring, and I do not seek to delve into particular aspects, nor in the discussions about the various interpretations in this regard. The forms of sensibility, space and time, are a priori conditions to representations. To think on representation, the understanding requires categories. Categories are a priori conditions to think the objects. Categories are divided into 4 groups: quantity, quality, modality, and relation. Proposal for a conceptual bridge. In this work, I will propose a conceptual bridge between the elements as basic substances and the elements as simple substances inspired by the Kantian philosophy. This bridge consists of considering the elements as a phenomenon that develops in time and space, and refers to a spectrum of infinite ways of perceiving chemical phenomena between 2 extreme forms. That is, the change manifested in time and abstracted from space, and geometric relationships manifested in space and abstracted from time. This slide shows a graphic representation of the conceptual bridge mentioned before. The colors of the bridge were intendedly selected as an analogy of spectrum. The colorful background of the simple substance represents the access through perception and the analysis framed by the categories a priori to the properties of the element, whereas the dark background of the basic substance represents the lack of properties directly accessible to our perception. The first scenario corresponds to the mechanical element. The second scenario corresponds to the geometric element, GE. MEs are ontologically material entities. They can react with each other, forming a transition state to produce material compounds. The transition state forms a temporary barrier that is clearly defines a before and an after. GEs are ontologically formal entities that, through geometric relationships, interact with a formal entity called interaction node and another GE. The interaction node is a formal structure which has all the information inherent to the reaction potentialities. In other words, it constitutes a during. Along with GE, an interaction node represents reaction patterns abstracted from time, which can be described by interaction diagrams. According to the proposal of this work, the atomic number can be understood as the number of protons in the case of the ME, and also as an order number without material reference for the GE coinciding in the numerical value, but not in the conceptual nature. In short, ME occurs in time abstracted from space. It has an atomic molecular nature. In its unit of analysis is the molecular structure, and the idea of atomic number is the traditional one, while GE occurs in space abstracted from time. It has a formal nature. Its unit of analysis is the chemical reaction in a geometric sense, and its atomic number is ordinal. Both ways of perceiving the chemical element are compatible and complementary, and constitute the way in which we can decipher the information concentrated in the basic substance, which, as knowing subjects, we cannot access directly. Prospects and possible projections. In the following slides, I would like to share some topics I'm working on without conclusive results yet. In general lines, I seek to relate the idea of geometric element with some previous works on reactivity and periodic table. Representation of reactivity. To represent the reactivity of the elements understood in a geometric sense, abstracted from time, showing the network of interactions in the context of a reaction without appealing to the idea of causation and the temporal sequence that it entails. I use the strategy in which the interacting substances are represented by numbers, which make up points in a system consisting on concentric circle diagrams. The central idea is to order the substances that are represented in this way in a different order from the one in which they naturally appear in the reaction, according to a timeless parameter. In this way, the idea of sequential appearance of interacting substances is abandoned. The proposed model, which I call the interaction diagram, consists of four concentric circles which represent from the outside in the reaction medium in blue, the reacting entities in green, the reaction intermediates in yellow, and the reaction nodes in red. In this way, it is possible to represent the reactivity of the elements and the compounds in a geometric sense. On the right part of the slide, I show as an example the representation of the oxidation of bromine acid. At the beginning of the current century, Eric Serry reformulated the concept of triad, using the atomic number instead of the atomic weight for its definition. In this way, the triad resulted from integers. Also, the author suggested the use of atomic number triads as a possible secondary criterion, based on the fact that atomic number is the only essential property of chemical elements if they are considered as basic substances and not simple substances. In 2018, I proposed a representation of the periodic system where the primary criterion is given, as is usual in current tables, by the increasing order of the atomic numbers, and the secondary criterion is established by the formation of triads of atomic numbers in a logic of generation of triads, in order to cover all the known elements and some hypothetical ones. The table starts at element 0 and ends at 171. Although the proposed table is based on triads of atomic numbers in a geometric sense, the fundamental relationships in the architecture of the table is given by the trees of periodicity, symmetrical structures of interrelated elements by means of triads, which contain 20 elements each and are proposed as an alternative to traditional groups. In periodicity trees, main in yellow and secondary orange, and internal branches of the main and secondary in green are presented. The branches correspond to the groups in the standard periodic table. The table does not require the use of electron configurations and does not employ quantum numbers or any other quantum considerations. There are 9 periodicity trees, 8 with similar symmetry and 1 central. Among the 8 with similar symmetry, there are 4 pairs of elements from 68 to 100 and to 71 to 103 that are part of 2 trees. These elements would have a structural function as well as being part, in some cases, of the chemical periodicity. One of the most discussed points about the periodic table consists on the position of the elements that are below scandium and yttrium. Being the postulated options, lanthanum and actinium, or lutetium and lawrencium, in this proposal, the 2 pairs are below scandium and yttrium. Tree 3 is the frontier tree of a symmetry change in the secondary branches. Therefore, I think the problem should be associated with group 4, since below titanium and zirconium, and due to their chemical properties, both hafnium and rutherfordium, as well as cerium and thorium, could be positioned. According to this proposal, any table in the plane is a partial manifestation of a more complex relationship and necessarily limited and incomplete. It could be an analogous case to the problem of reflecting the continents of the spherical Earth in a projection in the plane. Inconsistencies, distortions, and incomplete relationships are necessarily produced. The choice between one table or another is mainly for pragmatic reasons. Final considerations. In this work, I propose that between the notions of the elements understood as basic substance and simple substance postulated by Paneth, it is possible to think of a conceptual bridge made up of infinite ways of perceiving the elements between 2 extreme forms. Elements perceived in time abstracted from space, and elements perceived in space abstracted from time. In the first case, we have the mechanical element, and in the second, the geometric element. It is important to highlight that these 2 forms are not opposite, but compatible and complementary. They allow to manifest different aspects of the chemical elements or the same aspect from a different perspective. In this work, I also propose that the reactivity of the geometric elements can be represented by means of interaction diagrams and their relationship with other elements by means of closed structures called periodicity trees, which occur in space. And I present a projection in the plane of those structures. Finally, it is important to highlight that this work is at an initial level of development. I would like to conclude with a quote from Jorge Luis Borges. And yet, those who picture the world as unlimited forget that the number of possible books is not. I will be bold enough to suggest this solution to the ancient problem. The library is unlimited, but periodic. If an internal traveler should journey in any direction, he could find after untold centuries that the same volumes are repeated in the same disorder, which repeated becomes order, the order. My solitude is cheered by that elegant hope. Jorge Luis Borges, extracted from the Library of Babel. Finally, thank you all for your attention, and comments and questions are welcome, but please do it slowly so I can translate.
Thank you very much for actually, I didn't remind you, and we have 15 minutes for questions, so there's lots of clapping going on. So who would like to begin asking a question?
Could I ask a question?
Fazad, yeah, go ahead.
Yeah, I think I understand space abstracted from time, and that makes sense in terms of basic substance to me. But I don't understand why simple substance would be time abstracted from space, because with the mechanical aspect that occurs in time, which I understand, reaction, process, and all of that, I can't imagine that without space being involved. So I don't understand why time abstracted from space is a necessary part. If you could explain that more, I'd appreciate it.
Mm-hmm.
Si es necesario el espacio abstraído del tiempo, lo que pregunta.
No, que entiende uno de los extremos, pero no el del tiempo abstraído del espacio. Can I ask you again, Farsad? The one that you were talking about was?
The one that I would like more explanation is time abstracted from space as a description of the mechanical.
El tiempo abstraído del espacio, digamos, sería el elemento mecánico. La idea sería tomar como una simetría, como una disociación del espacio-tiempo, como formas de percepción. De manera que en los dos casos se deja como constante la otra variable. Eso es en la forma de percepción para luego construir el objeto de elemento. Digamos, hay una especie...
Porque es necesario tener el otro extremo en el espectro.
No sería necesario, sino sería necesario como propuesta para la síntesis. Yo creo que clarificaría de esa manera, planteándolo como los extremos.
O sea que es necesario para poder trabajar después el espectro.
No, inicialmente se trabajó el espectro, digamos. Es necesario, digamos, es una vía alternativa para intentar la comprensión.
Okay, I'll try to be as faithful as I can to the translation. But in order to have a perception, you need both sides to work on the concepts. Space abstracted from time and time abstracted from space. Since this work is also under development, they are different aspects that need to be developed in depth. And also I think that the most developed idea right now is the geometric element. This is the one that he's working on with all
Porque es
the.
una forma de aproximarnos que está en desarrollo, no es una alternativa. Digamos.
Yes, it's in development, under development right now. So and he's focusing on the geometric element right now.
Okay, good. Quick follow-up then.
Yeah.
Are the two, time abstracted from space, space abstracted from time, coincident so that you would have both operative at the same, together always?
Okay,
Or
then-
are they?
Sí, sí, sí. De hecho, por ejemplo, la interpretación de la mecánica cuántica de Copenhague sería en el espacio y en el tiempo simultáneamente.
Okay, yes. And when they exist, he's referring to the Copenhagen's quantum mechanics, that they have both existing at the same time.
Okay, great. Thank you.
You're welcome.
Just to follow up on that, in some more radical physics approaches, we sometimes change the number of spatial dimensions or the number of temporal dimensions. So you might even have two temporal dimensions. I don't know if that is an interesting suggestion for you or not.
Ella está diciendo que puede haber más de una dimensión del tiempo, o sea que el tiempo puede tener más de una dimensión, pueden ser dos
Lo que
dimensiones
pasa es que
temporales.
yo tomo el tiempo como forma de percepción en el sentido kantiano.
Okay.
Y además esto está fuertemente influido por la lectura de una década de Borges.
Yes.
Entonces,
Okay. So he is only using one time dimension because he's based on the Kantian perception, the Kantian perception, and also because these ideas are highly influenced by years of reading Borges. So yes, we almost had a quarrel because I wasn't using a quote from Borges in my own work. So yes, this is the light, his beacon.
Very good, thank you. Eric.
Hi, thank you very much, Alfio and Andrea. I have a question. There was made of the group 3 question when you showed the slide with many different triads. Can you please explain that? What was the idea that this could resolve the group 3 question, or was it saying that they were both equally correct according to this view? I missed the point, I'm afraid.
Okay, quiere saber cómo esta propuesta puede resolver lo del árbol 3.
Bueno, la idea no sería tanto resolver, sino plantear una alternativa.
Okay.
La idea que yo estoy trabajando ahora, de la que no tengo resultados concluyentes, es que más que una tabla hablamos de un espacio periódico. En el espacio periódico no existirían propiedades lineales, sino laterales. Si quieren...
One. Okay, so this proposal will not solve it, but pose an alternative of thinking the table not as in 2D, but in the space, and this means that they are not linear properties,
laterales y espaciales.
but they are spatial and lateral, because it's in a 3D.
Y que entre el grupo 3 y el grupo 4 hay un cambio de simetría estructural. En ese cambio de simetría...
Okay, between 3.3 and 3.4, there's a change in symmetry.
En los árboles, la simetría estructural en los árboles.
The structural symmetry in the trees,
los
between the
árboles
trees.
frontera, existiría una división más difusa en ese sentido.
Okay, and between different frontier trees, there would be a non-conclusive distinction or blurry distinction. Would you like to see the slide again?
Yeah, please.
Okay.
If possible.
Sure.
Acá volvemos y vamos.
Here.
Y aquí tenemos
Okay.
el árbol 3.
Okay. There's
Y
3,
este es el
3,
4.
and that's 3, 4.
Acá se observa, por ejemplo, la línea principal, que serían los grupos de la tabla periódica, son siempre laterales, a la izquierda de un lado y a la derecha otro. Y la línea secundaria, que son los grupos B, están hacia el lado contrario y acá hacia el interior. Por lo tanto, entre acá y acá hay un cambio de simetría. Ese cambio de simetría es el que hace que las líneas internas con las laterales se conecten con las otras.
Okay, what he's saying is that you have the primary branch here on the left in this tree, and on the other side is like a reflection, like a mirror reflection. But when you take a look at 3-3 and 3-4, this is reversed. And this change in symmetry is what makes the connections, the lateral connections that he is talking about. So we need to see this more in a 3D way than in a 2D projection to be able to see the
geometry. Es una idea que está en desarrollo.
But again, it's under development. So,
y la idea es no pensar en tablas lineales, sino en espacios tridimensionales.
Okay.
Por eso la analogía con los continentes y los planos.
Okay. The idea of comparing or using the analogy of the continents and how they are misrepresented when we use the plane is the one that he's projecting here, because in the plane you need to think of this in a spatial distribution instead of in a plane, because this helps to understand the spatial interactions or the spatial relationship between the elements of different frontier trees.
Exactamente. Okay? Igualmente esta es una aproximación todavía.
Okay, so we are not there yet. It's an approximation. It's a
Thank you.
You're welcome.
Thank you very much. We have a question from Safia.
Yes, I have a question, and I actually want to understand whether I have understood him correctly. First, are both the levels actually transcendental? I mean, the space without time and time without space, are they both transcendental, or which one of them is transcendental? And a second question is there any epistemological difference, asymmetry between the two levels, between basic substance and simple substance, or there isn't?
We will answer the first question first, and then I will ask you to repeat the second one.
Okay.
Okay. ¿Quieres saber si los dos extremos son trascendentales?
En el sentido estrictamente kantiano, digamos acá, hago una interpretación particular de Kant. Por eso no es kantiano, sino inspirado en Kant. Digamos, digamos, las formas de percepción sí son trascendentales. Lo que acá agrego es una disociación en el espacio y el tiempo que no está en Kant. Entonces es digamos, una inspiración kantiana, pero no es estrictamente trascendental en el sentido kantiano.
Okay. If you analyze this strictly using Kantian perception, forms of perception, it's not exactly Kantian, but it's inspired by Kantian perception. So in this case, for this proposal, they are both relevant, but they are not, they are derived from Kantian perceptions, but not exactly Kantian. I don't know if that answers your question.
So they are not transcendental. None of them is transcendental.
They are transcendental to this work. but this is still in progress. So in order to have other applications or to apply, this to other topics, everything is under development. So once this work moves forward, we may be able to discover where it can be or which questions it can solve later on.
So both are transcendental or just one?
Both are, las dos son trascendentales para vos.
Sí, 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 para mí sí.
According to him, yes. Not for Kant, but for him.
But then how are they actually at the same time phenomenal as well?
¿Cómo están las dos al mismo tiempo? ¿Existen al mismo tiempo o no existen en realidad alternativas?
No, lo que yo planteo es justamente en el espacio de la percepción, en el sujeto
Una que es
cognoscente.
constante y la otra.
Claro, uno puede pensar en un caso y luego pensar en el otro, pero el tiempo externo no tendría nada que ver con el tiempo interno.
Okay, so this is related to internal time and external time. External time can be abstracted here, and you can think of one of the extreme forms, and then think of the other and do it separately, referring to an internal time. The external time, which I think you're talking about when you say if they exist at the same time, that time that you're referring to would be the external time. And it has nothing to do with thinking these two extreme forms. Like that, okay. Don't kill me, I'm just a messenger.
And my second question was, is there any epistemological asymmetry between the two types of substances, or they are at the same epistemological level?
Epistemology, I cannot understand the other word, sorry.
Is there epistemological difference between the both?
Difference. Okay. ¿Hay una diferencia epistemológica entre los dos elementos?
Sí, o sea, en un caso se desarrolla en el espacio, la reactividad se desarrolla en el espacio, y en otro caso se desarrolla en el tiempo. Lo mismo que la permanencia, digamos. En un caso hay una noción distinta de permanencia y cambio.
There's a difference between them, and it's related to the permanence in change. So for one of them, it's set in space, and for the other one is set in time.
La idea es esa, que la estoy trabajando ahora. Es una disociación, pero como la disociación no puede ser total, sí puede ser disociado en cuanto a la percepción y a la construcción del objeto de conocimiento.
O sea que para el análisis dejas uno fijo,
claro,
y el otro
digamos, y el otro se desarrolla.
Okay, so he's developing that, and to do so, one of the parameters must remain stable or fixated, and the other one is the one that is developed.
But how would we determine which one remains stable?
¿Cómo determinamos cuál es el que queda estable?
Digamos,
lo definís a priori.
Lo defino a priori, digamos, justamente.
Okay.
En un caso yo percibo percibo en el espacio y desarrollo el objeto de conocimiento en el espacio. En el otro caso, percibo en el tiempo y desarrollo el objeto de conocimiento en el tiempo.
Okay, that is defined a priori. You decide first which one is going to be fixated and develop
objeto de conocimiento.
The knowledge object or the object of knowledge later.
But isn't it that for Bennett, it was actually the basic substance was basic and permanent in a sense, isn't it?
Está preguntando por lo de Panet. Si para Panet no era permanente el objeto.
Bueno, Panet también, sí, digamos, era de una fuerte inspiración kantiana. Lo que yo trato es de reinterpretar a Panet, pero manteniendo la idea de sustancia básica y sustancia simple. pero también sería para Panet, sí es así, digamos. Pero yo veo esa propuesta en realidad no lo que quiso decir Panet, sino lo que quiso explicar Panet. Entonces,
okay, this work aims to reinterpret what Panet wanted to say, not what he's not questioning what he said, but he's reinterpreting the explanation of basic and simple substances.
Thank you very much.
Thank you so much. I hope I answer at least one.
Puede ser muy difícil de entender porque estamos acostumbrados a pensar el cambio en el tiempo y no el cambio en el espacio.
Okay, this may sound difficult to understand because we are used to think about changes in space and not in time and not in space. That's it?
Yes.
Okay.
Okay, well, we'll thank our speakers and we'll close the official meeting now. And thank everybody for having come. And I hope that this was fruitful and enjoyable. I'm sorry that Jerry wasn't here because I think he would have enjoyed all of the talks because he thinks about a mathematical conception of the periodic table. So I think he would have found it very fruitful, but he wasn't here, unfortunately. So thank you very much, all of you. And we have our last session tomorrow, and we'll leave the floor open now for people to speak. We had a very fruitful and interesting discussion yesterday for those who stayed. We went on for another, I think another hour and a half or something, chewing things out, and it was very good. So I do encourage you to stay and join the discussion and start discussion, provoke each other, and see where we go. So now the floor is open, free for all.
Okay, is there anything you want to say?
Mark, you've unmuted.
Yeah. I was going to say the thing that I see as being intermediate between the basic substance and the simple substance is actually the gas phase elements. So now, of course, some of the helium, neon, argon, etc. The gas, in many ways the basic substance, the gas phase substance, the simple substance is the same thing. But the thing that appears to unify the elements is to look at the elements in the gas phase. Some of the elements very easy to get into the gas phase, other elements very, very difficult, carbon, tungsten, etc. But it does seem that in the gas phase, the gas phase elements, they're very interesting because you can compare things like first ionization energy, and you can start to think about things like atomic radius. And this seems to be a very interesting sort of intermediate state. So I wonder if you have any comments on that.
Can you make that a bit clearer? What do you mean that the noble gases would represent this interesting, what, pivoting?
We have the idea. We have the idealized basic transcendental elements, and then we have the real, or the actual substance in the test tube, if you like. And I personally think the intermediate state between these are the elements in the gas phase. But these are the elements normalized, where you can actually make direct comparisons between the elements and measure such things as atomic radius and first ionization energy and electron affinity, and quite fundamental sort of structure and reactivity ideas.
Sí,
Okay.
What are you getting at?
que no comprendo bien la pregunta. Pero,
Can you pose your question again, probably in a more simple way, so we can try to attempt?
So if in the basic substance, the element only has atomic number and an associated symbol, and in the simple substance, we have the element in test tubes. We can actually model it, and I personally think the intermediate state is the elements in the gas phase. So and the elements that are naturally in the atomic gas phase state are the noble gases. All the other elements, we have to do some work on them, put energy in to form the gas phase element.
Well, except for oxygen, nitrogen, and
But that is not the gas phase atom.
Dice
Oh.
que
Why not?
están entre la sustancia
Oh,
básica.
because
It's
sí.
Serían los gases.
O2, Cl2, Br2.
No, porque serían intermedios, están dentro de nuestro pensamiento, o sea, dentro de están en el sujeto, y el puente está en el sujeto como percepción y como construcción del conocimiento. No sería en el sentido físico, sino en el sentido de objeto de conocimiento. Y en un caso tenemos objetos formales y en el otro caso objetos físicos. Esa diferenciación sería solamente en la simple sustancia.
All right. What Alfio is saying is that we are not talking here about physical substances, but the bridge, the spectrum, it's a perception within the subject. It's how we perceive and how we build knowledge.
Dentro del sujeto cognoscente.
Within the knowing subject.
Yes. Luego, como sustancia simple, puede ser gaseoso o sólido, eso viene después. Cómo el sujeto logra conocer.
Okay, so this conceptual bridge is trying to reflect how the subject understands and perceives and learns. And the physical stage of the elements, of the actual elements, it's something that goes further.
En los supuestos hay un caso en que el objeto es meramente formal y en el otro es totalmente físico.
¿En cuál es el físico? ¿En el mecánico?
En el mecánico, sí.
Okay, and the physical element is related to the mechanical state and the formal?
Formal, como un objeto geométrico, okay. Tal como Kant lo plantea en la crítica de la razón pura. Ahí sí tomo Kant. Tomo la geometría como construcción y la mecánica como construcción, pero aplicada al caso del elemento.
Okay, and the other extreme form, the geometrical form, it is deeply influenced by Kantian proposal.
En crítica de la razón pura.
I don't know the name of the book.
Cómo la geometría es una ciencia y cómo la mecánica es una ciencia. Pero aplico esos conceptos a la distinción de Panel.
All right. So that distinction between simple and basic substance is influenced by Paneth, but also applying the Kantian point of view or explanation of geometry.
Como ciencia geométrica, no aplicada a los elementos.
Not applied to the elements.
Yes.
He is applying that framework to the elements, the analysis of the elements. So it's not that there is actually something physical or elements in the spectrum between the mechanical and the geometrical elements, but a way of understanding. The spectrum is about a way of understanding, of perceiving and understanding knowledge. Wow. This is like going to the gym. Or worse.
Can I say something, changing the subject, if I may, for a moment?
Yeah.
I'm probably going to miss most of tomorrow's meeting. I have to go to Las Vegas, of all places. Maximum temperature 103 or 4 tomorrow. I'm doing a radio interview with National Public Radio, so there. I'll try and catch some of the early part of the meeting before leaving, but I just want to say thank you to all of you. Thank you to especially to the organizers. But it's been really nice meeting. At first, I had doubts about the idea of a meeting lasting the whole week, but actually, it's been rather nice to be able to get up early, in my case, in the morning and check in and see all these great talks. Please send me email if you have any more comments, and keep in touch. And I suppose at some point we're going to have to put our heads together to decide where the next meeting is. I don't think there's been any talk of that in the committee yet. But so thank you, Michelle. And as I say, I probably won't catch much of the meeting tomorrow.
Well, we'll miss you tomorrow, and have fun in Las Vegas. Don't gamble all your money away.
No, I will keep well away.
I'm sure the air conditioned in the casinos, Eric.
Yes.
I'm sure there is.
You know what? Anyway,
they can afford it.
Of course, they have the slot machines in the airports, just in case you still have some money on the way out. They can get you one final time. Anyway.
Yeah, but you're not going to drive like Hunter Thompson then.
No. It's a 1 hour flight.
1 hour more. Sure.
Fear and loathing and all that, yes.
Well, have fun in Las Vegas, and do because you should be able to join the YouTube live streaming, if nothing else, right? Even if you don't have, I don't know how it works, but as you know, there's the included group, and then there's also the YouTube
but they both require an internet connection.
Right.
I think if I can get it at the airport, which should be possible.
And probably not in the casinos, right?
Oh no. Going to the casinos.
But Eric, did you get that that link to that paper I sent? The one momentum, basically imaging orbitals. And the paper is called Momentum Space Imaging of Sigma Orbitals for Chemical Analysis. And there's a rather remarkable line in here. But basically, it says, and it gives the impression that whereas that the orbitals are routinely visualized using this technique of photoemission orbital tomography.
Okay. No,
and it actually, it just implies that it's absolutely routine now to visualize orbitals.
Could you explain what tomography is?
I'll put the link in the in the notes, and it's
3D scanning, 3D imaging.
Well, it just gives it says, it says here. This has spurred many successful efforts to image orbitals. Orbital imaging has also been applied to the investigation of chemical bonding, and this whole paper just gives the impression that it is now absolutely routine to image orbitals.
Who are the authors?
Well, it's called Hags, Yang, Egger. I put the link in the
Oh, good. Yeah, I see it now.
It's a technique I hadn't heard of before, but
yeah, that's what I wanted. And then there's a reference number 7 or something. I was just looking at it. Reference number 7 talks about tomography or whatever that is. But
yeah,
well,
I mean,
don't know it.
All right, thank you. Thank you.
We'll all
Mark.
have to get tomographers together or something, or have a
yes.
or buy a tomographer online or something like that.
Yes.
See if Amazon sells them.
Yeah, so they got some lovely pictures, but I'm not sure. They might well be measuring electron densities, but whether I'm measuring orbitals, of course, is
yeah. Well, it's sometimes that word is used interchangeably. Sometimes that was part of the confusion in 1999 when those people claimed to have imaged orbitals. Yeah.
Right.
Exactly. I'm just looking in the references to see if there's any reference to that discussion, but it doesn't look like it. Oh, wait a minute. No. Yeah, well, actually, Eugen wrote a paper on this in which he seemed to think there was something in it.
Right.
Yeah, there was a paper called Orbitals, Something or Provocation. Remember that one?
Yeah.
Reality or Provocation or something of that form. Yeah, I've backed out of that particular discussion. It just got too technical.
Yeah.
And if they mean different things by the word orbital, then of course you don't know where you stand.
Yeah, the paper that you gave on the first day, I think, on bonding. How far are you on with this, and what you plan to do with it? I think it's a really important.
Well, apart from the critique from Keith Tabor, which I haven't completely cleared up yet, I thought we've been corresponding, and I think I've cleared it up. But anyway, that was the first and simplest attempt to explain why kinetic energy is important. I then moved on to the other. I just want to go more deeply into it. I want to try and get to the position where I can make some sort of judgment between the Beta school, who are denying kinetic energy or the importance of it, and the kinetic energy school. And I believe it's, as I said, an important debate which philosophers of chemistry can maybe contribute something to. At least they shouldn't be ignoring it. And just, as I said in the lecture, be concerned with whether orbitals, in this case, bonding exists or not. So you may think this is an inconsistency because I did get involved in a debate about whether orbitals exist or not. But I think the reason for that, there are different cases. In the case of orbitals, mathematically, they don't exist. I was bringing this up yesterday to Michelle and asking her for her view, because it's a complex number. Whereas in the case of bonding, we don't have that way of making a more clear-cut conclusion. So to my mind, exploring whether bonds are real is pretty much a waste of time. And that's what's been done by a number of people in the philosophy of chemistry literature up to now. Most recently by Vanessa Seifert, who has been writing papers on this. She had a paper in Chemistry World, not a paper, a short article, in which she said, this is an important debate in the philosophy of chemistry. I don't think so. But the debate the chemists are having is important, because it's getting at what bonds are actually like. Of course there's bonding. How could anyone deny there's bonding? You know, that would be denying the existence of two or more atoms
Gravity.
binding together. I mean, that would be absurd. But whether a bond is, I'll tell you why I think Robin Hendry is keen on real bonds. I think he's keen on real bonds because he's keen on structure. And the reason he's keen on structure is because he believes that structure cannot be recovered from quantum mechanics, which is true as things stand, you know, because of this Born-Oppenheimer question. So if structure is not reducible to quantum mechanics, for Hendry, that means emergence is at play. So he's wanting to, if you like, justify the importance of structure. That's why he likes the idea of actual bonds existing in it. That's my take on it.
The analogy with gravity is an interesting one, because you might say, well, gravity doesn't exist. We now know gravity doesn't exist. You know, there's just space-time geometry, and the idea of gravity is just a kind of epiphenomenon. But I mean, for most people, if you fall over and hit the ground, you know, something's happened. We call it gravity. You know.
Yeah. Well, I mean, now to ask the question whether gravity exists would be like saying, well, does electromagnetism exist? And yeah, I mean, existence questions are the domain of metaphysics rather than physics, chemistry, but there is a thriving metaphysics industry, and if you go to their conferences, you understand almost nothing. At least I almost understand almost nothing. They're living in a parallel universe sometimes.
Some physicists don't like, I came across some that didn't like the notion of forces at all. And instead they really hung on to the notion of the curvature of space-time as a replacement, and they didn't want to talk about forces, which was really difficult for me conceptually. I found it very, very hard to wrap my head around that, because there's got to be something that's warping the space-time, and if it's not force, then what is it? You know, what's going on? Is it just happening to be warped in this? I don't know. It was too confusing for me. But
it's mass that warps it. But they would argue they wouldn't call that a force. They just say that's mass, the effect of mass.
That's right.
Exactly. There's no such thing as electromagnetic force. There's just exchange of particles.
Exactly.
It's just language, isn't it? It's just a different description, you know.
Yeah.
Yeah, as I saw something a couple of days ago, and it was saying, with some physicists saying that when he started, it was what the universe is full of particles, and then it's full of fields, and now it's just full of information. And you're just like, okay, right, it's. Yeah.
It's actually now it's full of misinformation. That's the problem.
Yes. Yes.
And distractions.
Yeah, I would like to add something, is that maybe the issue of the reality of bonds has been relevant in the philosophy of chemistry recently, because we have at least two competing models that say different things about what a model is: valence bonds and molecular orbital models about bonding. So I think that is the reason why the metaphysical issue has been relevant for some philosophers of chemistry. This idea of having two models that are empirically equivalent, but conceptually describe different what a bond is, and is generally reduced to the issue of localization or delocalization of electrons in bonds. So maybe that's the reason why philosophers of chemistry are interested in what a bond is, if they took just these potential models. For me, maybe I will send you the paper, because my lecture precisely is about this thing.
Oh.
So yeah.
Okay. Well, I don't want to.
But you will see it on the PSA philosophy of science association because I will improve the arguments we have been putting into this discussion. It's not about metaphysics, actually, it's just about having competing models that are equivalent empirically, but conceptually completely different, or different descriptions about the bond. We are not taking the metaphysical question because we understand that there are certain, I will say, superior models that were those that you were talking about. I'm not so well informed in these kinetic models, but I will try to introduce it to see what happens now. Doing this comparison between the potential energy models of bond, if I can call it now in this way, and the kinetic energy kind of. I will try to improve that for November, but for tomorrow it's just about valence bonds and molecular orbital descriptions.
It's not the potential energy or kinetic energy model. They both contribute. The question is which one contributes more. Right? So that's not a case of
okay, I got it now.
And
one
also,
or the other. Okay.
And also, as Eric was saying, it's a question of knowing what the bonds are, not whether or not they exist. So, and as you said, you're not tackling the metaphysical question of whether or not they exist, but what are they like? Because the different theories are going to describe them in different ways. Yeah.
When it comes to the two models,
exactly. So it's the issue of representation.
When it comes to the two models, say the valence bond or molecular orbital theory, they have been shown to be the same in the limit.
Yeah.
Right. So that's it. That's
you can make it both the same.
There's no debate. They're the same.
But even if they're like mathematically equivalent, because you can change, or in the best approximation, you will have the same mathematical representation, right? The way you read those mathematical functions is completely different. No? You have like molecular orbitals in one side that are completely delocalized, and in the other hand, you have like hybridization and localization of electrons in bonds, classical way. No.
That's only
the problem is that they are equivalent. When you make all the approximations at the final, they tend to converge, but what they say about what one is different, or the way I understand the situation. I'm not like into the more advanced computation of valence bonds and molecular orbital, but it looks like in the qualitative terms, the way they interpret those results is completely different. And I hope that this is true because it's the base of my lecture. But as far as I know, that's the reason why there's had been so much discussion about the fact, is that they are mathematically equivalent, but conceptually different in the sense how they represent what a bond is, or what electrons are doing in molecules, more like that, in that way.
Yeah. Okay. One last comment on this. If we read our ontology from our theories, and if our theories tell us that actually these two models are fundamentally the same, then I would conclude that they are the same. In other words, we can't draw ontological conclusions about what is actually the case by looking at the crude. The crude model has, hybridization, as you say, but as soon as you do a more detailed version of valence bonds, you've not got hybridization. You've got atomic orbitals that are being combined in a somewhat different way as they are being combined in molecular orbital theory. You're dealing even with the same objects, but combining them in a different way, which in the limit converges.
I will not try to ontologize those models. I know that there are approximations of quantum mechanics. That's not the idea. I'm just trying to tackle the issue of representation, how they represent, and how this issue of representation has to deal with different ways in which philosophers of general science are taking into account what these kind of models are. No? There are some that are advocates of incompatibility, others about different perspectives about the same phenomena. So we are still discussing things with Margaret Morrison, Roman Prick, this kind of people. So that's the idea, to try to advance some examples of multiple modeling in quantum chemistry in order to tackle this issue of multiple models and how we end with that. That's the idea to explore. Because in chemistry, we don't have this idea of having big theories. We have such like multiple models for a lot of things. Like, acidity models are a kind of example of this. So we are trying to use examples of different models of the same phenomena in chemistry to see how we can contribute to this problem in philosophy of science.
Also,
the philosophy of models.
We should maybe distinguish between representation and existence, right? I'm talking about the existence.
Yes,
question.
exactly. Yeah.
It's not the same.
You're right.
You can represent it, and you're not necessarily claiming it is like this. You're saying, well, I've got students at secondary level, therefore I represent it like this. I've got second-year undergraduates, therefore I represent it like this. They're not claiming to be, the final picture.
Yeah, you're right.
Okay, that's.
I'm not putting forward this metaphysical conclusion at all. I'm just saying that in the way in which chemists have been modeling wave functions, there are some issues that can be interested for the philosophy of models in general, and see how much can we learn about this discussion.
Yeah.
So if you are not going to be here, maybe I will send you some draft I have or something like this. Maybe you can check it.
Juan Camilo, are you're in the PSA session that Olympia organized, is that correct? The one in November?
Yes, sir.
Yeah.
Yes, sir. Give me a sec. There is a bus just coming in front of my flat. Okay, now.
Yeah, I was just trying to remember if it was in fact you. And then we have a third person, I believe.
Yes, she's from Finland, I think. She's talking about we don't remember some issue about the periodic table, but I don't remember exactly what was her argument about.
Okay, yeah. And unfortunately,
maybe some context of discovery.
Unfortunately, it's on the very first day, first thing in the morning of the conference.
Yes, you're right. I got it.